Hello everyone, welcome back to the channel. In our previous videos, we discussed what a Web Application Firewall is and the different types of WAFs. In today's video, we're going to understand how a WAF actually works, step by step, from HTTP request flow to attack detection and blocking. By the end of this video, you will clearly understand. First, let's understand the HTTP request lifecycle. Whenever a user accesses a website, the request does not directly reach the web server. The actual flow looks like this: user, WAF, web server, application, database. When a user types a URL or submits a form, the browser sends an HTTP request. This request first reaches the Web Application Firewall. The WAF acts as a security checkpoint. Only after inspection, the request is allowed to reach the web server. Similarly, the response from the server also passes back through the WAF before reaching the user. Now let's see what happens when a request reaches the WAF. The WAF does not simply forward the request, it deeply inspects multiple parts of the request, such as URL, HTTP headers, cookies, parameters, request body, HTTP methods like GET or POST. For example, if a login request contains suspicious input, the WAF immediately analyzes it before allowing access. Next is signature-based detection, which is the most common technique used by WAF. Here, the WAF uses predefined attack signatures, similar to antivirus signatures. For example, SQL injection patterns like OR 1 equals 1, XSS patterns like script command injection keywords. If the request matches any known malicious signature, the WAF blocks it instantly. This method is very effective against known attacks, but it may not detect brand new attack techniques. To overcome that limitation, WAF also use behavior-based detection. Instead of focusing only on content, the WAF monitors user behavior patterns. For example, too many requests from one IP, repeated failed login attempts, sudden traffic spikes, automated bot activity. If the behavior looks abnormal, the WAF can identify it as a brute force attack, bot attack, or DDoS attempt, even if no signature is matched. Now let's understand security models used by WAF. First is the negative security model, also known as blacklist-based security. It blocks only known bad patterns and allows everything else. Second is the positive security model, or whitelist-based security. Here, only known good traffic is allowed, and everything else is blocked. In real-world environments, most WAF use a hybrid approach, combining both models for better accuracy and fewer false positives. After inspecting the request, the WAF takes one of three actions. Allow. The request is safe and forwarded to the server. Block. The request is malicious and dropped. Log. The request is suspicious but allowed and logged for monitoring. Many WAFs also use learning mode, where traffic is logged first to understand application behavior before enforcing strict rules. The job of the WAF doesn't end with request inspection. When the web server sends a response, it again passes through the WAF. The WAF can hide server details, mask error messages, add security headers, prevent data leakage. Finally, the clean and secure response is sent back to the user. To summarize, this is how a Web Application Firewall works. It sits between users and the application, inspects every request and response, uses signature-based and behavior-based detection, applies allow, block, or log actions. Protects applications from real-world attacks. In the next video, we'll do a live demo showing how WAF blocks SQL injection and XSS attacks. If you found this video helpful, please like, share, and subscribe to the channel. See you in the next one.